Hi, in this video we're going to be looking at the uncertainty principle. We have a particle that is in a state described by this wave function. We have the domain where the particle exists. We know that B is a constant. And we want to make sure that by calculating certain parameters, we can make a comment about the uncertainty principle that relates the position with the momentum of this specific particle. So how do we do that? Remember that the statement of the uncertainty principle that it's applicable in this case is the uncertainty in the position times the uncertainty in the momentum along the same direction should be larger or equal to a constant, in this case h bar over 2. So that means we have to recall what are the definitions for those uncertainties for both the position, it's given here, and the momentum. And remember, this is basically the definition of standard deviation, where we have to calculate the expectation values of two different entities. The first one is, for example, in case of the momentum square, or the square of the expectation of the momentum. In the case of the position, the expectation value of the position square and the expectation value square of the position. To evaluate the corresponding uncertainties. And finally, depending on the product between those two uncertainties, we can make a comment regarding the agreement or disagreement between our result and the uncertainty principle. Our observables being both the position and the momentum, just recall the general expression for the expectation value of an observable. So let's get into it. We bring up the values, so I end up with this quantity for the uncertainty in the position. I'm going to do similar to the momentum, where this one was 0, this one was h bar squared times beta, so I end up with this value. When we put them together, multiplying one times the other, what we end up having is uncertainty in the position times uncertainty in the momentum is equal to h bar over 2. So that is consistent what we have in terms of the expectation for the uncertainty principle. And we just notice in particular that this result is exactly the smallest possible uncertainty that we can have. Because remember that the uncertainties between two are bound by this equal value. They can always be larger, but never lower. The lower bound is always when this relationship equals h bar over 2, and this is exactly what we have in this particular case. In summary, what we did is, given a wave function that describes the state of a particle, we calculated different expectation values for the momentum and the position, and we put them together in order to calculate now the standard deviations of those observables, position and momentum. And then by multiplying those uncertainties, standard deviations, together, then I get the expression that corresponds to the uncertainty principle for this particular system. And I noticed that it's exactly at the lowest bound for the statement regarding this general statement of the uncertainty principle. Okay, so this is how you do this type of calculations. I hope this is helpful. With that, I am signing off.